Welcome everybody to the HSRP redundancy protocol. This is a Cisco proprietary protocol for redundancy. Okay, let's take a look at it. Now, one of the questions you ask yourself, do we need redundancy? It's not only needed but required. In a network, we must have redundancy. So our clients, whether they be internal or external, can still provide the information, the data that we need or that they need. All right, so questions you would ask yourself. Well, how fast can the failover happen? If you fail, how are we going to come back? How quickly can we come back? How is the client aware to switch from one gateway to the other? How does that happen, right? Are you going to have multiple gateways in your PC? I think not. What if a WAN link fails? What happens there? Okay. What if it's not your gateway that fails? What if it's the other side of the router that fails? So HSRP does answer these questions, and we'll look at it in a second. It is a proprietary Cisco protocol, so meaning you don't use it in Cisco routers. By default, the hello timers are 3 seconds, and the hold timers are 10 seconds. What does that mean? When you're using HSRP, which is used within the interface of the routers, these routers talk to each other and they send hello messages to the router saying, hey, I'm still here. Hey, I'm still here. Hey, I'm still here, every 3 seconds. So if in 10 seconds it doesn't hear from you, your neighbor router, right? Or whatever router, it will say, oh, he must be dead. I'm going to go ahead and switch, and I'm going to now start taking his data for his clients, and so they can get to where they need to go. So it does address those issues on an active standby state, and we'll talk about that. All right, and here they are. Gateways are organized into standby groups. Now you can have multiple groups. You don't have to have one group. All right, in the labs, we're only going to configure one group so you can get the concept. And there's one thing that I've been trying to get across this entire course. Concept. You need to understand the concept of it, because it's a 90-minute exam, people, and I'm going to be saying it throughout the rest of this course. It's a 90-minute exam. You're not going to configure everything that Cisco says you need to know, okay? If you recall, in the CCNA 120, one of the requirements in their web page was what? VSAT. Did you see any VSAT questions or simulations in your exam? No, you did not. They also said you needed to know 3G. Did you see any 3G questions in there? No, you did not. Or simulations. And when we get to it, I'm going to show you. Okay? This is the Cisco Pressbook. This is not a security class, right? Look how thick this book is. Look at that. It's thick. My God. That's a lot to read. Okay, so this is not a security class. We learn about security, basic security, like enable password Cisco, enable secret student, access list, right? Switch port security, right? But the book talks about, okay, AAA authentication using Radius, using TACAX. I use Radius in my wireless course, right? So the wireless users authenticate to a Radius server so they can get allowed to get into the network, okay? That's all it is. That's what you need to understand. Ports they're using, 1645, all right? So this right here, I think is what starts here. That's it. Any syntax? No syntax. They give you some little bogus, hey, type words where you don't tell you what it is exactly you need to type. All right. What am I getting at? Just because you go to a Cisco website, or the Cisco website, and you look at their prerequisites, or not the prerequisites, the requirements, the topics that are going to be covered, it doesn't mean that they're going to put them all in there. If not, you'll be taking this test for 8 hours. So what I give you is what you need to pass the certification. Something comes to mind that I remember someone told me a long time ago. We're not all born knowing everything. So let's say when I got to telecommunications, I knew all my cabling, I knew all the Cisco stuff. They hired me, but I told him, hey, listen, I've never worked with these particular types of equipment. He goes, the boss, the man, goes to me, you weren't born a switch tech. You'll learn as you go. And I'm telling you, what I give you is what you need to know to get that piece of paper that's going to allow you to get the job. I even go above and beyond sometimes and give you things that you really shouldn't, not to confuse you, because sometimes I feel, man, I give them too much. I may confuse them. All right, because it's not, you're not going to see it. You may get a question, one multiple choice with a print screen. Maybe if they want to get really whatever, drag and drop. But a simulation on TACAX and Radius, nope. Now, this was Security Plus or CCNA Security. I'd be like, yeah, let's get down to it. It's a CCNA, okay? So keep that in mind. This is a routing and switching class. You need to know how to route. You need to know about switching. It's not a security class. Radius and TACAX. Let me give you this. Switch port security. You see how simple it is, right? Guess where that one's at? They may ask you questions on it in the CCNA, but when you get to CCNA security, yeah, that's where I saw it. Okay? I actually have to configure it. When I saw it, I laughed. I'm like, oh my God, this is what I teach in the CCNA. All right? They have it in the CCNA security. What I'm trying to say is, do not go crazy. Okay? Because I'm getting questions that doesn't make sense. All right? And as far as I'm concerned, Network Plus, every certification has a different thing. Network Plus has their requirements. CCNA has their requirements. CCNP, even though we're taking CCNP stuff in here. CCIE, and so forth. One of the things Cisco says, if you don't know it, know where to get it. And those of you that have taken my courses before, know this. For the CCIE hands-on, they actually have a browser that only goes to the cisco.com webpage to allow you to look for the configuration for DMVPN, for whatever it is that you don't remember, because you're not supposed to remember everything. But if you don't know it, know where to get it. Not only did Cisco tell me that, but you know who else told me that? When I worked at Bell South, our trainer. They go, if you don't know it, know where to get it. So let's say, for whatever reason, it's not enough inside my course, which I doubt. You got the internet. You got Google. It's in the dictionary, for God's sake. Go out there, type it up. We have YouTube, Wikipedia, TechNet, all these different places you can go and get the information. Okay? And the best thing of all is be curious. Practice, practice, practice. Create different scenarios. Just don't. Nobody handed me anything. I create things. Oh, what if I do this? What if I do that? Let me put this here. Let me put that there. I'm not trying to chew you out. I'm trying to motivate you. Okay, to tell you, don't worry about the Bible. Okay, don't worry about it. This is not even one. This is 2 friggin' books. You'll be sitting there for 8 hours if you got to take every last question on these books, because they're extremely granular. Hey, you know what? If you go through the Cisco Academy and you pass each and every chapter question, chapter test, and the midterm and the final, they should just give you the CCNA, because it's that difficult. How do I know? Because I was a Cisco Academy instructor. Okay? And I had to take all those tests. All right? And it's very, very granular. So what I'm trying to get is, like, don't sweat it. Listen to what I'm saying. Get that information, because what I'm giving you is what you will need. And if I reiterate something, make sure you get that. All right. And if something's not there and if I just fly through it, there's a reason for it. It's good to know for an interview. If some individual in their IT job tells you asks you a question, that's them. And just so you know, if you don't know already, every IT job out there is not the same. Just like all routers aren't equal, all IT departments are not equal. Everybody uses their particular software. Everybody has different SOPs, standard operating procedures. Okay? For those of you that say that I don't tell you what the acronyms mean. All right? Standard operating procedures. All right? So it doesn't really matter. Just be as best as you can. So if a recruiter calls you, hey, listen, we need somebody to, you got to know this, and this. Oh, yeah, no problem. Sure. Boom, hang up. And then friggin', if it's not on any of the courses that you've taken from me or from anybody else, Google it, YouTube it, find a book on it, study it, practice it, do whatever you need to do. But if you don't take the initiative yourself to be curious and want to be the best in networking or programming or whatever it is that you do, you're in a world of hurt. Because this is not getting any easier. This is getting harder. And the competition out there is insane. Insane. So why should I hire you? And remember, you gotta be nice. You can't be like me. You can't walk in there and say, hi, how you doing? My name is Lazaro Diaz. Then you scare the hell out of them. And then they don't want to hire you. Okay? So you gotta be in there, hey, how are you? How you doing? Nice to meet you. You gotta be nice. All right. Anyway, I'm going off. But just I see a lot of questions that to me are like, what? No. Okay. So step it up, get motivated, do your research. Okay. Because just like I showed you those two thick books when I used to teach Microsoft in the classroom, yeah, Active Directory. I saw an Active Directory book. I kid you not. This was one book, an Active Directory. Okay. I had a book in that particular college. Do I have one around here? No. Well, just think of half the size of this. Okay? Half the size of that. That and about that big. Half the size of that, somewhere, cut it in half, and then that big. Is that all Active Directory? Oh, no. But that's how I'm telling you. Don't freak out. Don't freak out. Enjoy it. This is your passion. Let's go for it. Anyway, I went on a tangent here. All right. Breaking down HSRP. Yes. Gateways are organized into standby groups. When you're creating HSRP, you're actually there is no HSRP command, so don't look for it. It's standby, and you do it under the interface. So you create a standby group. I think it's from 0 to 255. You can create all these different groups. And you can create something like a redundancy there, but the true redundant protocol is GLBP, which is also Cisco proprietary, but they don't want it now in the certification. So don't worry about it, okay? HSRP. One is active and the other one is standby. How is that? Because the virtual IP, the VIP as they call it, the ghost IP, is an IP that you will configure in that standby group on all the routers. I believe it's up to 8, okay? That you say, okay, this is the virtual IP. This is what we're going to use, okay? And then you go to your clients and you put that as their gateway. So if one router goes down, the active router, because its priority is higher than the rest, he's the active router. Traffic is going to go his way, right? If he dies, then the next one takes over, right? The priority, the next higher priority out of the other ones, right? You got to design that. You got to make sure it is. By default, 100, okay? He takes over. He becomes active. Now he takes all your clients. Traffic goes that way. Client may see a bleep, okay? But it's like 2 or 3 timeouts, and then he goes. All right, virtual router ID and MAC addresses are generated. Yes, remember the ARP process. There is an ARP process to all this, okay? So you do get a virtual MAC address, one virtual MAC address, where GLBP creates multiple MAC addresses. But we're not going to get into that. I'm just letting you know. See how I go beyond? Okay, your virtual IP, this is just an example. This is not going to be like in the lab. It's going to be an example. The virtual IP is 10.1.1.1. You go standby 1, IP address 10.1.1.1. Now, this you need to know. The MAC address 0000040C07 AC1. This is a specific MAC address. Okay, they're 1, 2, 3, 4, 5, 6. So the first, because these are hex numbers, the first 24 bits identifies it as a Cisco vendor ID. Okay, a Cisco vendor ID. The next 16 bits is HSRP ID, and the last 8 bits is the standby group number. This you need to know. You will have this in your resources for you to have. All right, so this is important. Obviously, we're dealing with virtual IP addresses. We know that, but know this breakdown right here. Redundancy is not, no, wait a minute, I went backwards. There you go. You have the active router. There's your configuration right here. Okay. Interface, whatever, F00, G00, whatever it is you're using. Standby 1, that's the group number. This is the VIP, the virtual IP address. Priority 120, defaults 100. And here's the range that I just told you, 0 to 255. Okay. Preempt, what is that? What is that? Okay. So when the active router goes down for whatever reason, a backhoe hit the cable, somebody did something, whatever the case may be, the standby router takes over, right? After 10 seconds, the standby router takes over. So when you fix the problem on the active router, because that's the router you want, when it comes back, he has a higher priority. So it's going to overthrow the other lower priority routers. So when he comes back, he says, I am the overlord of this network. I am now the leader. Okay, so he takes his place back in the network. You can also track, standby 1, track whatever interface on the other side. Remember I said if the wide area network goes down? Well, standby 1, track that interface. So we know if that goes down, hey, stop sending traffic this way, send it the other way. Okay, so it does that as well. And you have timers. One of the things, because there's also something called VRP, okay, standby HSRP, long time ago, 90s. Okay, they actually, their timers were 3 seconds, seconds. VRP, which came out I think 5 years later after HSRP, they which is not vendor specific, they were already in milliseconds. Right? Oh my God, it's faster. Let's go to that one. Okay, and then GLBP came about, Cisco proprietary. They got milliseconds too. And so does HSRP. So they're pretty much the same. One has benefits over the other, obviously. One has benefits, one's vendor specific, the other one is not, and things of that nature. And they have more features and things like that. But you're worried about HSRP. All right, so you have the timers you can mess with, but look what I put here. Careful processor cycles. Okay? If you're constantly really quick, okay, saying, hey, tell them every so many hundred milliseconds. You're generating that. Your processor is like, okay. Be careful. And lastly, all clients will have to be configured with a VIP, obviously. So when the active router goes down, right? Told you that. When the active router goes down, they know to switch over. Because what are you gonna do? What are you gonna do if a client now goes down? Hey, John. Yeah, I know you're 30 miles away from the NOC and the remote access is down, but also this client doesn't have any connectivity because the gateway is down. Can you think you can drive over here? So now your people are down. And believe me, this is real world. I've seen this when I was in telecommunications. If something will happen in the switch and it goes down, I mean, literally, I was about 40 minutes away. I had to get in the car when I was on call, obviously, and run over there. By the time I got there, all the VPs and Ps and anybody else was on this call trying to find out what was going on. It was about 6 hours later. Hey, we're up and running again. Okay. No ARP from active routers, go to standby. That's what it means. So The clients are like, hey, I'm not getting any ARP. What happened to the ARP? I don't see any MAC addresses coming back. Now it's coming from this guy now. Oh, okay, let me go this way. So that's how they know. So this is what HSRP is, okay? This is what you need to understand what it does. Yes, we will have a lab on this, okay? So don't worry. But again, don't kill yourself. What I'm more scared of, not so much a configuration, because you're not going to be configuring it, okay? But they will ask you about this right here, okay? They will ask you about that there. So pay attention to that one. I'll see you in the next. All right, welcome back. I told you there's going to be a lab, and here it is. I even got the little configurations right here. Okay, the little configuration right here. So the whole point, these are your clients. You can see this is down right here, but we'll fix all that stuff when we get inside the lab. All right, this is just a picture. All right, so if you want to mimic the lab, here you go, 2 computers, 1 switch, 3 routers, and a server. Okay, so you can see how it is. But either way, you can always pause the lab. I'll see you inside the lab. Welcome to the HSRP Lab. Remember, HSRP is proprietary to Cisco. We do have VRP, which is not vendor specific. And we also have GLBP, all right, which is also Cisco specific or proprietary. And but it works a lot better as far as redundancy is concerned. So you got to take a look at your network and see which protocol or redundancy protocol you want to use. In this case, for certification purposes, obviously, we're going to use HSRP. And the whole point to this is if these clients are trying to get to that server, right, at the moment, let's see which way this client is headed. So let's do a trace search to the 10.1.4.2. I believe that's the IP address. And right now it is going out to the 10.1.1.1. And then, oh, there it goes. Then to the 10.2.1 and then to the 10.1.4.2. So the 10.1.4.2 obviously is the end where we want it to go. The 10.1.2.1 is this way. If you look at this router right here, let's take a look at its show IP int brief and 10.1.2.2 or the 2 network. So the 2 network is going this way. So right now communications are going this way. So we don't want that. So we want to go ahead and if that goes down, what's going to happen is he's not going to be able to communicate with anybody. So we're going to go ahead and configure HSRP under the interfaces, and we're going to use a virtual IP address, right, which is 10.1.1.10. And they're going to be configured on both of these routers. And you go to your clients, you're going to use those particular gateways. The difference is that now, if traffic is going this way, right, if this goes down, or if this is the active router, it's actually going to take the traffic that way, and we'll do a tracer again to verify. But if either one of them goes down, it will go ahead and the other one will turn to active if it's a standby, and it will go ahead and take that traffic and send it on its way. The user will notice very little interruption in network connectivity. So let's go ahead and do so. Let's come over here, get all this gibberish out of the way. We do a config T, conf T, interface G0/0, and then we're going to say standby, not HSRP, standby, and a group number, and then the virtual IP, which is going to be 10.1.1.10. Always forget that D. My fingers are not doing the walking. There we go. And you see the change, the group 1 state, initialization state, and it goes to different states until finally it becomes either standby or active. Now, what we're going to do also is do a standby 1 preempt. What does that mean? I mean, even from the presentation, you should know, but just to reiterate, if, and you see now it became active, because there's no other HSRP router. So preempt means that it will overthrow any other routers that has the lower priority than he does. And this usually occurs when this router goes down for whatever reason that the other router takes over. The other router that took over has a lower priority. So when he comes back up, he's going to overthrow that router and then he'll take over once more. All right, so let's set the priority. Standby 1, priority, and then 150. Oh, all right, UWR. And if you want to look at it, what you did, you can do a show standby. And then you can see there that the virtual IP address, this MAC address, all right? Remember the MAC address that we put in the presentation? You need to know those bits. You need to know those bits and what they mean. That is extremely important. You can also see the hello timers, okay? That's 3 by default. So every 3 seconds says, hey, I'm still here, I'm still here, I'm still here. After 10 seconds, it doesn't hear hello. It says, oh, he's dead. I'm taking over for him. All right, and it shows you that preemption is enabled, that I am the local, I am the active router, the local router, and this is my priority number. Okay, and we're running group 1. All right, so let's go ahead to the other router, router 1, and let's move the lab over a little bit so you can see exactly. And we have room for the router to expand, and we can look at the configuration as well as we're doing it. All right, so we're going to go to int g01, config t int g0/1, enter. All right, so we're going to do standby, a group number, the IP address or the virtual IP address, which is 10. All right, you see the initialization state starting, standby, and then preempt once again. And yeah, this is if you have several active routers or what have you. And then standby 1, priority 0. And you can see that this router already changed to standby. It's a standby router because it had, by default, the priority is 100. So the other one's 150. So he knows he's active. So when this one came up, it knows already that it's going to be the standby router. Standby. And you can see that the active router indeed is 10111, which is the other router. All right, the standby router is local, and you can see the virtual IP address is 10110. Okay, and remember again, please, please, please memorize those different bits that you need to know. We went over this over the presentation, so you need to know these. Okay, so well, we're not done yet. Now we need to tell our clients, hey, we need to change your default gateway to the virtual IP address gateway, 10110. All right, let's do that for this one. What was that? 10110. There we go. So now, last time that we pinged from this computer, traffic was going this way to the 2, remember? And then to the 4. So let's do that again. Oh, not terminal. Command prompt. You can see, remember, it went to the 1, and then it went to the 2, and then it went to the 4. Okay, so let's go ahead and let's do a tracer this time. Let's see which way it's going. Still going in the same direction. Interesting, but let's ping and see what happens. All right, we're going to go ahead and, well, we have connectivity because we do a trace route. But let's see, we're going to interrupt the ping. Ping 10, or ping minus T, I should say. Ping minus T, 10.1.1 dot, not 1, 4.1, 2. All right, so we're going to do a never-ending ping. And what we're trying to do is we're going to interrupt it. And I'm going to interrupt it by simply disconnecting that cable. Hey, somebody out there with a forklift or a backhoe or something just went over our wire. So we're going to, oops, no, be careful what you delete. I'm going to take out that line. And let's see if this is still going to ping. It's supposed to be pinging, but let's go ahead and do it again. Hey, I'm still pinging. How is that? How is that happening? Which way am I going now? Let's do a trace search 10.1.4.2. And now, before, remember I said 2? Now it says 3. Now it's going this way. Okay? So if you look at this router, I mean, you shouldn't see any real changes to it. Its state is active, blah, blah, blah. So it's still the same thing. It took charge. Okay? It's going this way. So now that we have HSRP running, we have a virtual IP address that we're using. Our clients do not need to know, hey, that something happened to our network and it went down. So that's the whole point about HSRP. Okay? Let me put that line back up, which is straight through. And whichever, let's go F03 to G01. Okay, and let's fast forward in time. We get green lights. Okay, so the individual will never, maybe a little blip here and there when it goes down, but that's it. It will be nothing. You still have connectivity where you need to go. And there's a million different configurations, but what you need to get out of this, is the following. All right, the one, your clients will not be interrupted. All right, your clients will not be interrupted because you have that redundancy protocol that will say, hey, if I die, somebody's going to take over for me. Okay, and you need to understand that they use a virtual IP address. Then they use a specially designed MAC address that this portion right here will let you know, hey, this is a Cisco IP address. Okay, it's a Cisco, and this is a vendor specific number right here. All right, and this means that it's group 1. Okay, so this is the things you need to know. All right, and who is the active router and who is the standby router. So these are the things that you need to be aware of for the test. Doubtful that you'll be configuring HSRP. You may have to troubleshoot it. It may be a print screen. It may just be a multiple choice questions. But do know those MAC address bits. Know the HSRP protocol, what it does and what it can do and its purpose, and you'll be just fine. So you just saw how HSRP works. I'll see you outside the lab. Okay. We have little things here and there, but that's HSRP. It's no big deal. It's quick. All right. The whole point is to make sure these clients ping where they need to go using the virtual IP address. Okay. I'm standing here so you can see what the lab will look like. All right. So you can go ahead and mimic it, and you can use your own IP scheme. You don't have to use my IP scheme. You can do whatever IP scheme you want. All right. You don't have to follow my IP scheme. Do your own. All right. So, but the configurations are right there, and you see it's standby, and you're gonna have resources. It's gonna be there. You're gonna have resources not only on this one, on the other two as well, VRP and GLBP. They'll be there too. Okay, so but concentrate on this one. Okay, concentrate on this one and what it does. This is just a protocol that if one router goes down, the other one takes over. Let me tell you, this is reality because we used it in the telecom. All right, and we had to troubleshoot it one time, excuse me, which was another department that handled that, and they were like, "Hey, what's going on? What's going on?" All right, but they finally figured it out. I think an hour or two later. All right, what was going on with the HSRP configuration? So this is something you should know about the HSRP, but just keep in mind it's a CCNA certification. I don't care that they put some CCNP stuff in there. It's still 90 minutes. Okay, you're not configuring it. Just know what it is, what I pointed out. Okay, and just see how we did the lab, and that's it. You'll be good to go. See you in the next. All right, that was pretty simple, brief little section there. So let's go ahead and summarize what we have learned. Okay, basically, why is HSRP needed? Because of redundancy. It's required redundancy. We know it's a Cisco proprietary protocol, and look what I put there. The MAC address, the breakdown of the 24 bits, 16 bits, and the last 8 bits. You need to know what they are, okay, what they mean. You need to know that. Cisco vendor ID, one's the HSRP ID, and the other one just the standby group, okay? And then the configuration of it, you saw it. All right, standby 1, the IP address, the whatever, priority, default's 100. You can preempt to overthrow. I like that word. Overthrow the lower priority ones. You can track the interface on the other side of the router. And if you want to play around with the timers, you could. We didn't, but if you wanted to, you could. And finally, yes, all clients. Don't forget, your clients needs to have that VIP, that virtual IP address. With a Mac, that'll get that automatically. But you need to put the gateway of the clients as your virtual IP address that you just configured. All right. See you in the next.